And welcome to another video in our Geometry Basic Concept series. Today we are going to be looking at a second theorem in circles. So to solve questions in circles, you need to have the knowledge of multiple theorems. One theorem we have already discussed. Moving on, the second theorem of circles. This is also a theorem that is going to deal with angles. So I believe that there are 6 main and most important theorems when it comes to the topic of circles, out of which 3 deal with angles and 3 deal with side lengths. So this theorem that I'm going to discuss the derivation of tells us that all the angles subtended by a chord in the same arc are equal. Or in short, all angles on the same arc are equal. So what this means is that when I, let's say, have a chord in the circle, let's say that there is a random arbitrary chord in the circle, let me call this chord AB. A chord, by the way, is a line segment that is formed by joining any 2 points in the circumference of a circle. So a chord then divides a circle circumference into 2 arcs. There's a big arc AB and a small arc AB. The big arc AB is referred to as a major arc AB. The smaller arc AB is referred to as a minor arc AB. So the theorem states that if the same chord subtends multiple angles in the same arc, let's say, for example, there are these 2 angles, which the chord AB is subtending in the major arc. Let me call this first angle, angle ACB, second angle, angle ADB. Then these 2 angles will be equal. Angles subtended by a chord in the same arc are equal. And why is this true? Because if I take the center of the circle as O, then if I join, let's say, let me draw it in a different color. Let's say that I join OA and OB. Then angle AOB is the angle that is being subtended at the center of the circle by the points A and B. And angle ACB and angle ADB both are angles subtended at the circumference by the same 2 points A and B. So both angle ACB and angle ADB will be half of the angle AOB because angle at the center is twice the angle of the circumference. So that is why angle ACB and angle ADB will be equal, which means that no matter how many angles I construct on the circumference of the circle in the same arc subtended by the same chord, all of these angles will be half of angle AOB, which means that all these angles will be equal. Angle AEB will be equal to angle ACB, will be equal to angle ADB, will be equal to angle AOB will be equal to twice of angle ACB. Angle ACB will be equal to angle AEB, angle ADB, angle AFB, all these angles. So all the angles subtended by a chord on the same arc are equal. This essentially means that if, let's say, that the points A and B are subtending an angle, let's say APB, this is in the minor arc AB. Then angle APB will not be equal to angle AEB or angle ACB or angle AFB or angle ADB. Angle APB will be a different angle. Why? Because this angle will be half of the reflex of angle AOB. Half of the reflex of angle AOB based on the first theorem that angle at the center is twice the angle at the circumference. You can watch that video to understand this better. So angle APB will be half of reflex of angle AOB, which means that if I subtend another angle on the minor arc by the chord AB, and I call this angle AQB, then angle AQB and angle APB will be equal because both are going to be reflex or half of the reflex of angle AOB. So angles subtended by the same chord in the same arc will be equal. That's a second theorem in circles, and it also deals with angles. Thank you.